So a linear system describes a set of points. So we've seen a couple of different ones that are a linear system in previous lessons, a linear inequality in previous lessons. And I'm just going to pull up one example of that really quickly here from the previous lesson. So inequality here, we're going to represent this entire section of points. So this is our borderline, and then we have our entire section of points right there. Now, a system of linear inequalities puts more conditions on the points that you want. So a system is going to have more requirements to it. It's going to have usually one requirement is an inequality, a second requirement is another inequality, and then where they are meet or where they kind of both are included, that's going to be our system, and that's going to be our answer key to the system. Now, all points that we have must satisfy the system, and so we'll go through how we do that. So let's graph this system right here. So this is going to be our first one. Fairly straightforward. They're both in graphic form already, and we always want to make sure that our inequalities are in graphic form. So we have y is greater than or equal to 3/4 x minus 3. So let's graph that out. I'm going to label this here. So this is 2, 4, 6, 2, 4, 6, -2, -4, -6, and so on and so forth. Our first one here, y is greater than or equal to 3/4 x minus 3. We're at 3 right there, and then 3/4, so up 3 over 4 will be right there. That is going to be a solid line due to the fact that it is equal. So again, something to watch out for. Do we have a solid or a dashed line? And so we have a solid line right there. And this is the point 0, -3, and this is 4, 0. Happens to be our x and y intercepts, and we are greater than, so we're going to shade in this region up here, and I'm going to put in y is greater than or equal to 3/4 x minus 3. And so I'm going to shade in this region. I'm not going to do it too heavy because we're going to have to do some more shading yet. I like to do it in multiple colors. So we can see where it's overlapping, because they're going to be a little bit different. Second one here, y is less than or equal to -1/2 x plus 2. So we're over here at 2, and now it's going to become a little bit of a mess here, but 0 to -1/2 down 1 over 2. Here's our next point. So this is at 2, 1. Notice the different colors. We're going to draw a line through there, and that line is going to be dashed as it has to do with, or it is less than. And then we're going to shade in underneath, and I'm going to shade this in upways. And sorry, I should have put in there. Y is less than -1/2 x plus 2. There we go. It's becoming a little bit of a mess. That's why I got to make sure to put that in there beforehand. So these are our two inequalities. This is what we call a system. Now a system could have an infinite number of inequalities. In this case it just has 2. But we want to see, where do these two inequalities, where are they both included? And that is this area right here. I'm going to shade it in brown. Okay, so I'm going to shade this in brown. This is our answer region. Okay, this line would be included in the answer region. This line would not, as it's dashed. This one's solid. And this region right here is included in it. Now, the important thing to remember as well is that this point right here, it looks like they both go through 4, 0. Not actually a part of that because it's a dashed line. But if we pick anything from inside here, it has to be a part of that. Now, what that means is that a point in here is going to satisfy this as well as this. A point over here is only going to satisfy the first one, not the second one. And a point down here is only going to satisfy the second one, not the first one. We need to find the points which satisfy both, okay, where both of them happen to work. And if we want to take a look at one point that does that, let's pick the point 0, 0. It seems to be inside there. So 0 is greater than or equal to 3/4 times 0 minus 3. So 0 is greater than or equal to -3. That works. Okay, that shows that that one is satisfied. And for the other one, 0 is less than -1/2 times 0 plus 2. says that 0 is less than 2. That works as well. So the point 0, 0 is in fact satisfies both of our inequalities, and so it is a part of both of them. So a system just mentions that it is includes both of them. Now again, if we have like a third or fourth or fifth inequality, which we will take a look at in the future, then that would be, they would have to satisfy all of them, and so it would have to show them all. Now if you use Desmos or something like this, it's going to have like a darker region where all of them are, instead of where just one or two of them are included.